Chapter 5, Section 2, Making Waves. For this investigation, we were to learn the motion of a wave pulse, calculate the speed of wave pulse, observe the standing wave, investigate the relationship among wave speed, wavelength, and frequency, make a model of wave motion, distinguish between transverse and longitude waves. For the first part of the investigation, if there is a standing wave, a row of people would stand up and sit down, and the wave is moving across the stadium. As a person of the wave, you move up and down. You stimulate the person next to you to move up and down, which is causing a wave. The variables that can be involved in the wave is how fast the wave moves, amplitude of a wave, and which direction the wave is moving. The investigation, we have a coiled spring set 60 centimeters apart, and our first part is to show a transverse wave, which will carry energy from one end and return it to where it started. Okay, so first part. A wave moves across So show how it was moving. The coils 90 degrees for a transverse wave. What we learned is a transverse wave is a wave motion of medium is perpendicular to motion of the wave. Next part of the investigation is to calculate speed. To calculate speed, you take the distance traveled and divide it by time elapsed. So I did a table for that for the investigation, and here is an example of how to do that mathematical. First, this. Okay, and let's say that we know that the distance is equal to 2 meters, and that the time elapsed is equal to 0.2 seconds. All you do is the math equation, pretty easy. 10 miles per second. Pretty easy. Next part of the investigation is to learn about the pulse. The pulse will be faster when the coiled spring is tightened. When it's like this, it's a slower wave. You tighten it, it makes it quicker, so that's going to have to do with the frequency, and it's going to affect the wavelength. I have to go over wavelength. That's pretty important. So, here's the vocab. Coil starts here, goes up, goes down, goes up again. Okay, this is called the amplitude. This is the crest. And this, from here to here, my bad, from here to here is a wavelength. Pretty cool. Okay, so frequency. Frequency is the number of time a wave moves up and down each second. The energy from my arm is using the spring as a medium to transfer my energy. For water waves, the medium is the surface of the water. That I can't go into. A periodic wave is a repetitive series of pulses. When there is a large amplitude in a vibrating string, the string is loud. A soft sound has a small amplitude. The wavelengths, which could also be written as this, is the distance from one crest, which was the top of the wave, from one crest to the other crest. The period it takes to complete a pass of one cycle of the wave. It's the time required to follow a cycle. Period equals 1 over frequency. The next thing I think is important is how to find the wave's speed. So if you have wave frequency and the wavelength, you can multiply those together to get the waves. Also, it can be written as V, wave speed, equals frequency times wavelength. And my checking up would be that a wave is a transfer of energy without a net transfer. A transverse wave is a wave which motion of medium is perpendicular to motion of force. A longitude wave is a wave of motion that the medium is parallel to the direction of the motion of the wave. A node is a spot on the standing wave. Just standing wave is a little different. A node is this part right here, and an antidote is the spot where the standing wave is largest. So, antidote, I don't know where the antidote is. Okay. And that was Chapter 5, Section by Rebecca Sobratos, Period 1. April 12, 2011.